Email Australian cyclone tracking has become far more accurate and sophisticated since Cyclone Tracy. The morning of December 24, 1974, Darwin residents were preparing for Christmas festivities, completely oblivious that a powerful cyclone had just made a sharp, unforeseen turn and was bearing down on the city. Tropical Cyclone Tracy struck Darwin early on Christmas morning, killing 65 people and causing about $800 million worth of damage. The first warning that Darwin was under threat only came at lunchtime on Christmas Eve, about 12 hours before the onset of destructive winds, meaning residents had little time to prepare. But such a destructive scenario is unlikely to play out today, as vast technological improvements in cyclone tracking mean the Bureau of Meteorology, BOM, can warn of a cyclone's projected path and the likelihood of landfall several days in advance. Computer weather models and the observational data upon which they rely have improved by an order of magnitude, giving communities far longer lead times to prepare for severe weather compared to Darwin 45 years ago. Video: The aftermath of Cyclone Tracy, ABC News. The technology saving lives. The map below illustrates the improvements in accuracy for the projected path of Tropical Cyclone Tracy, using models from 1974 to 2010. The improvements in computer models allow us to have greater confidence in the forecasts that they produce, which in turn allows us to warn for weather events much, much further in advance than we would have been able to in the past, Mr. Morgan said. These days, computer models do most of the grunt work of weather forecasting, allowing meteorologists more time to interpret the data and warn the public of any potential threats. So the more and more over time that computers are able to do that grunt work, the more and more resources we have available to communicate the danger of these events to the public well in advance, Mr. Morgan said. In that sense, computer models are improving community safety during weather events very significantly. Why does BOM use so many models? When a cyclone forms, some uncertainty or conflict in the computer modeling can still occur when the path of a system is unclear. That is because forecasters rely on a number of models which don't always see eye to eye. BOM, together with the CIRO, has developed its own model, the Australian Community Climate and Earth System Simulator, ACCESS. But it also looks at several other models from meteorological agencies around the world, including Japan, the US, the UK, France and Canada, as well as the ICMWF, a collaboration between more than 30 European nations. The reason we use so many different models is because each model has slight differences in the way it's constructed. So we want to take into account the spread of different possibilities that are out there that different models may provide to make the best assessment of what the forecast is going to be, Mr. Morgan said. If they're all telling us the same story, then we say we're very confident in terms of the forecast. It's when they tell us slightly different things, That might be when we use words like uncertainty, but what we're really meaning is that there is still a spread in the possibilities of what's going to happen. That's particularly the case with cyclones, which are notoriously erratic. They're very difficult to forecast. How do the models work? Weather models divide the atmosphere into a large number of grid boxes. Weather observations, temperature, wind, pressure and moisture, from the atmosphere and ocean, which are collected from an array of equipment such as balloons, aircrafts and buoys, as well as satellites and radar, are fed into the models. Then at each grid point, mathematical equations based on physics that characterize how the air moves, and how heat and moisture are exchanged in the atmosphere, are applied and stepped forward in time, predicting what the weather will be. The sky is the limit. Computer models may be sophisticated, but Mr. Morgan said they were not about to replace the role of a meteorologist anytime soon. It's still going to take a meteorologist with their knowledge and experience, what they've seen before and their understanding of the science, to interpret what those computer models are telling us, he said. In terms of what the future holds, scientists are continually trying to improve the accuracy of weather models, and this boils down to two things: the ability to run them at a finer resolution and to increase the amount of observational data that can be ingested at the start. Resolution refers to the size of the grid boxes into which the atmosphere is divided. The current global weather forecasting model has a grid of 25-kilometer wide squares, but BOM's forthcoming model doubles that resolution to 12 kilometers wide per square, which allows for greater detail. The sky is the limit in terms of what we would like to be able to achieve, and I think we will still be working on computer models hundreds of years into the future, because I think there will always be things to work on, Mr. Morgan said. More stories from Western Australia.